Hello students, straight back again for some more practice problems. Here we got chapter 3 review. How does a pure substance differ from a mixture of substances such as lemonade? And a number of different things you could have put here, but the key ideas is a pure substance has a composition does not vary. And in a mixture, the composition does vary. One of the ways you can answer it. There are other acceptable ways on that one. And here we want physical properties or chemical properties, and we'll just identify them as P or as C. Piece of silver can be hammered. Hammered, not going to change the composition, so that's a physical property. Piece of charcoal glows red, gives off heat, becomes a clay ash. All that stuff's indicating that is changing into new substances, so we're talking about a chemical property. Table salt dissolves in water, remains its crust and water evaporate. We got a physical property there. And the Statue of Liberty, once the color of a new penny, turned to a bluish green as it formed a thin coating called a patina. That's another chemical property. So make sure you can recognize physical and chemical properties. Again, two samples of the same substance have different physical properties. So, can have different physical properties. Such as shape, state, and mass. And there's a lot of other ones that would also. We talked about extensive and intensive properties. Any of the extensive properties would be different. Again, they have different chemical properties. And must have same chemical properties because the composition is fixed, because of a fixed composition. All right, one statement for solid, liquid, and gas describing particle arrangement and spacing in each. Okay, solid. Particles close and regular spacing, regular arrangement. Liquid. Particles are also close. And free to move. Gas. Particles far apart. And free to move in all directions. Let's go. Yeah, there's some descriptions. Again, these could have been a little bit different. These wordy answers, you can have some different things. We get to numerical answers. You're going to have the right, correct numbers. So suppose you measure the mass of an iron nail and find it to be 13.8 grams. You place the nail in a moist place for 2 weeks. When you retrieve the nail, it's covered with custard brown coating and rust, and you place the nail on a balance to measure its mass. Will it have a mass greater than, equal to, or less than 13.8? In this case, it's going to be greater than, because the hot iron has combined with oxygen. Iron has chemically combined with oxygen. And physical change, chemical change, we'll just do a P or a C here. Wood burns, burn, chemical. Keywords. Pounded, physical, doesn't change the composition. Becomes green, indication a chemical change is happening. Baking soda in cooking dough causes cookies to puff with bubbles of gas when they're baked. Chemical change, bubbles of gas, indication a chemical change is happening. Pan of water boils. Boiling is a physical change. Soap and water are used to clean up a spill of grease. That's a physical change, just causing things to dissolve. Mothballs vaporize. See that word vaporize, that's all you see. Physical change. Number 20. Aluminum can combine chemically with various substances, but never reacts to form simpler substances. Is it an element, a compound, or a mixture? How do you know? Is aluminum a substance? So, lots of questions there. So, aluminum, I'm going to use abbreviation. We should know it's an element because we've memorized it off the periodic table, but from what we have here, it's an element because it doesn't react to form simpler substances. It's an element and is it a substance? And if it's an element, it's going to be a substance. So all elements are substances. Number 21. Mineral, whatever that is, cassiterite, is combined as a commercial source of tin. It's a compound of the elements tin and oxygen. A 1 kilogram sample contains 788 grams of tin. Is it possible to predict the mass of tin in a 43.5 gram sample mined in South America? And yes, compounds always have the same composition. And they didn't ask us to, but I'm going to go ahead and look at how we could figure it out. So if we got 788 grams of tin in a 1 kilogram sample, you want to know how many grams of tin are in a 43.5 kilogram sample. And then we just do a little calculations there. Do a multiplying here. We got a 1 there, so that makes it easy. We're just going to end up multiplying those two, divide by 1. So 788 times 43.5. 34,278 grams of tin in that sample. Now we should only have 3 sig figs, so I'll round it to 34,300 grams of tin, or switch it to kilograms would be 34.3 kilograms of tin. So, but our answer is really up here. It's all you had to have. A little extra stuff down there. The elements carbon and sulfur are solids at room temperature. Can you reasonably predict that the compound of these two elements will also be a solid? And no. Properties of compounds. Usually are different from the elements that make up the compounds. So that takes care of the 3 review work. We should be getting close to time for a quiz now, so make sure you understand all the things through the practice problems, the study guides, everything else. That's it for now.